Ladies and gentlemen, a very, very good evening to you. My name is Alistair Chapman. I'm chairman of the Wellington Trust, and welcome to this month's lecture given by the Wellington Trust. And I think it is going to be an extremely interesting evening. Before we go on to the topic, may I just give, for those who are regulars, they will know this briefly, housekeeping announcements. You can give a question to Paris Mangriotis, our speaker tonight. To do that, if you look on your bottom bar, you will see a Q&A icon. If you click on that, would you please type your question in? And then during the course of the lecture, my co-trustee, Jenny Mosley, will be collecting these questions and will be posing the questions to tonight's speaker on behalf at the end, on behalf of you at the end of the lecture. There will be a recording taken, or a recording is now being taken of this lecture, and you will be sent the link to that recording automatically within the next few days, once it's been looked at, tidied up, edited, and whatever. And do please spread the word if you feel this is a lecture that others you know would have been happy to hear. I get the feeling it probably will be that for a number of people. All they have to do is to go into our website at thewellingtontrust.org and find the section and click on the link to our past lectures, and there it will be. Now, with no more ado, I'd like to just pass on to our speaker tonight. Paris Mangriotis is a naval architect and engineering director at the London office of the worldwide company ABL. Paris works with a team involved in marine claims, casualties, engineering analysis, and surveys. He has been with ABL and its merged predecessor LOC for 17 years. He has experience in representing owners' interest in the technical advisory and project management roles on a number of wreck removals. Back in the 2012 and 2014, Paris was the project manager for LOC, representing the owners and insurers of the Costa Concordia wreck removal, of which many of you may well remember the reports on television. It was quite a memorable and dramatic event. Earlier on in his career, which has been very varied, in terms of its scope of what he has done, Paris worked for Lloyd's Register of Shipping as a classification and technical investigation surveyor. He is a chartered naval architect and member of the Royal Institution of Naval Architects. And with that, I have nothing more to say. Enjoy the evening. And Paris, over to you.
Okay, thank you very much, Alistair, and thank you to the Wellington Trust for inviting me to give this lecture. It's a description really of the technical challenges that were encountered during this wreck removal project. This lecture was originally given to the Royal Institution of Naval Architects, so it does tend to be on the technical side, and it really highlights what was sort of novel in respect of this particular project, which I was lucky enough to be involved in. Okay. So the Costa Concordia was a cruise vessel built in 2004 in Italy, operated by Costa Concordia, a subsidiary of Carnival, the largest cruise operator in the world. The vessel itself had a capacity for 3,800 passengers and 1,100 crew, 290 meters in length, and 114,000 gross tons. One of the largest classes of cruise vessel with 13 decks. So the background to the incident was a maneuver executed during the first day of a 7-night cruise off the Tuscan coast. It's shown in this AIS recreation. The vessel approached the island of Giglio to conduct a tipping the hat maneuver, a sort of salute, which was not at all officially sanctioned. And during this maneuver, the vessel got too close to a rocky pinnacle, against which it collided at a speed of 16 knots. It subsequently ruptured 5 watertight compartments and lost power, drifting to a standstill, and then slowly coming to rest just outside the port of Giglio on a rocky outcrop, shown by my mouse up here. It proved to be a catastrophic error, and the vessel capsized. There was a massive evacuation, some of it orderly, and some of it requiring the passengers to crawl down on the opposite side to where the lifeboats were launched. There was a mobilization of local resources from the island, and very tragically, 32 crew and passengers lost their life. From a perspective of the vessel itself, it adopted a heel of up to 90 degrees as it floated up towards the shore, and then settled down on this in a depth of about 30 meters, at an angle of about 60 degrees to starboard, as we can see in the bottom right picture. The vessel itself had cross-flooding arrangements which are designed to equalize the heel when certain compartments are breached on one side, and thereby maintain survivability. However, the number of compartments that were breached were in excess of the ability of the vessel to remain upright. This is a picture of the following day after the tragic incident, and the vessel was declared a constructive total loss, which meant there's no value in trying to reconstruct it. The first task was to mobilize search and rescue services, who were in command for the initial period of 1 month. In the meantime, the anti-pollution services were mobilized, and we can see here a boom surrounding the wreck. In a situation such as this, the vessel's liability insurers and owners would be responsible for the costs of the bunker removal. Bunkers are another name for the fuel that's on board, and the costs of the wreck removal once a wreck removal order is issued by the coastal administration. And it is for them that my company at the time were appointed and for whom I was acting. The island of Giglio itself is a sort of picturesque holiday island that comes to life in the summer months. It has a very small port with servicing a passenger and car ferry around about half a dozen times a day, together with a small fishing fleet. The entire port was taken over during this time by a variety of emergency services who set up camp along the quayside. As well as the emergency services, there was a massive media interest, and they were kind of camped out night and day as it servicing the 24-hour news cycle to start with. And all of this made the coordination of the plan to remove oil and eventually remove the wreck more complicated, and certainly required a lot of sensitivity in proceeding. So the first task for the owners and insurers was very close engagement with the Italian authorities. Within a few days, a wreck removal order was issued, understandably, but the time to remove the wreck was not really appreciated, frankly, by anyone at that stage. And the methods and plans were at a very nascent stage. The prime task was to coordinate with the search and rescue teams, who had obviously priority in searching for any live survivors. And then once that operation was complete, really the sensitivity to the environment became the paramount concern, with a specific committee set up by the authorities to assess the potential impact. And that committee then handed over to the Italian Department of Civil Protection under Commissioner Franco Gabrielli, and a process was set up by presidential decree, a fast-track process to begin planning for removal of the wreck. The plans were discussed together with the Admiralty, and it was very quickly made clear that the wreck should be removed in one piece, if feasible, rather than cut up in situ, due to the environmental impact that that would have. And really, this one piece concept then dominated everything that was to follow. The engagement of multiple authorities was remarkable. At one point, there was probably 20 plus authorities and non-governmental organizations spanning Coast Guard, Navy, financial police, Alpine Rescue, an entire panoply of organizations who all understandably had a stake in what was to take place, and all of their concerns had to be addressed in devising an appropriate plan. The first task was to map both the subsea bathymetric profiles and the aerial situation in order to gauge how to proceed. A huge anti-pollution spread was mobilized, which encompassed absorbent booms, which are sort of foam boom used to soak up any pollutants. Ocean boom, which is used to provide a barrier to close up both the wreck itself and the nearby beaches and coves. Within 24 hours, a oil pollution contractor had been appointed under the command of a joint venture between Smit Salvage, a Dutch firm, and Neri, a Italian salvage company based in Livorno. The method for removing the around about 2,000 tons of fuel oil is called hot tapping, and I'll just play this video which describes it.
Hot taps are used to make an opening in the ship's hull without a spillage of oil. First, the base plate and valve are connected on the deck by drill tap studs. Hereafter, the milling machine is connected on top of the valve. The milling head drives a hole in the tank. When the cut is finished, the milling machine is removed. A hose, pump, or a specially engineered heater can now be connected to the valve. When the heated oil is pumped up to the surface, each tank is flushed 3 times to clean them completely.
Okay, so this is quite a standard process for removing oil from wrecks. What was unique here is the quantity of oil and also the sensitivity of the wreck itself, which was resting in a precarious position. Although it was in a 30-meter water depth, it was on a sloping shelf down to around about 100 meters water depth. So there was a concern that by altering the buoyancy of the wreck, it could upset the equilibrium and possibly set off a chain reaction where the wreck began to sink down further. However, none of this happened, and the oil was successfully removed over a period of about a month and a half. And by the end of March 2012, 2,000 tons of oil had been removed from 23 tanks on board. As I mentioned, the movement of the wreck was of concern, and a team, including volcanologists who are used to studying the minute changes in volcano displacement, were mobilized to check how the wreck was reacting to various bad weather events and movement of liquids inside. It was found to be settling over a period of about 2 months. It settled down by around about 1 meter, and later on that year there was a large movement of the wreck when a storm, which we termed the Halloween storm, on the 31st of October 2012 washed through. But by that time the wreck had been secured to an extent, tethered to the shore, and had stabilized. Once the oil had been removed, a international tender process was launched to find a contractor capable of removing this wreck in one piece. It was a fast-track process where 4 tenders were finally shortlisted, and they all had a similar methodology, which involved holding the wreck back against the shoreline and rotating it. Tenders which proposed dismantling were not taken forward due to the pollution risk. A successful contractor was mobilized towards the end of April, and a contract was put in place very soon after, which is a massive undertaking considering the value of this operation. The parbuckling concept, which I'll elaborate on in some later slides, involves rotating the wreck by pulling it away from the shore and thereby basically uprighting it. The technical concerns about the methods proposed were there was a worry that the superstructure of the wreck would bend and flex and wouldn't remain intact as the wreck was pulled over. The vessel's construction is such that it's designed to be quite lightweight, hence why the cruise vessels sometimes look sort of like they're unlikely to remain upright. That's actually because they have a low vertical center of gravity, but it does mean that the upper decks are not particularly structurally stiff, and so cannot be relied on as a point at which to pull from. There was concern that the bilge plating, the sort of fulcrum about which the rotation was to occur, might collapse due to the vertical pressures. And some tenderers were proposing to inject the wreck with foam buoyancy. Aside from environmental impacts, there was a concern that the decks were simply not strong enough to accommodate that much buoyancy. The refloating process itself was sensitive because the vessel could not be relied on to have any buoyancy at all. So all of the buoyancy had to be applied externally, and that meant that around about 60,000 tons of buoyancy had to be attached securely to this 290-meter vessel, and that meant that the longitudinal strength of the vessel was critical, so for it not to break into pieces, for example. The methodology itself consisted of project management, fabrication of sponsons, the stabilization of the wreck, parbuckling and refloating it, delivering it, and finally what was called site remediation, which meant cleaning up everything that was left behind. The successful contractor was a consortium between an American salvage company called Titan Salvage, who partnered with a Italian offshore services contractor called Micoperi, and it was felt this provided the best of both worlds, a creative salvage solutions proposed by the American contractor together with very good local knowledge of the Italian market, the Italian sensitivities, and access to a huge wealth of Italian engineering for carrying out the operation. The sort of winning points of the proposal were that all of the buoyancy to refloat the wreck would be applied externally without having to repair any damage on the wreck, which itself was sort of moving and constantly changing, so it couldn't be relied on to remain intact. There was a robust, what was called holdback system, where the vessel was anchored to the shoreline. Divers did not have to enter the interior of the wreck underwater, and a full support was provided for the wreck while refloating preparations were made. So it didn't need to rely on buoyancy during the winter months, which would have been very precarious. So it was really the belt and braces approach, one that could be relied on to work. This cross-section of the wreck shows the main components of the holdback and power buckling system. In this mode, we can see that the vessel is anchored using a chain. This was actually a set of 24 chains which were wrapped around the hull and led to towers which were installed on the seabed in around about 5 to 10 meters of water, secured to the rock with steel tendons. And at the top of these towers were two devices called Strand Jacks. These are hydraulic pulling devices which are very strong. In this case, they had a capacity of 500 tons each, and they were used to tension the wires, the dyneema, which is a Kevlar rope cable, and the chains which were wrapped around the hull in order to secure the vessel against movement. This is a what's called a finite element model of the wreck. It shows, it's a sort of mathematical model which shows a very exaggerated deflection, i.e. movement of the hull after it had been predicted to distort on having been rotated. What this showed was that there was a need to support the wreck on the seabed so that it would not deflect excessively once it was brought upright. And this required a bolstering of the number of underwater platforms from 3 to 6 by positioning additional mini platforms towards the aft end of the wreck. This was a mathematical model that incorporated all of the damage that was known to have occurred to the wreck from settling and also from the initial contact with the rocky pinnacle. This screen sort of describes the main components in plan view of the system to hold back the wreck and then right it. We can see that there were 3 main support frames which were purpose constructed in order to right the wreck onto. 3 mini platforms further aft, and an area of subsea rock pinnacle that had to be landscaped, which meant shaving off some of the parts of the rock so that the wreck could rest on it without being penetrated. This row of towers here was positioned such that it could hold the wreck against the shore. The locations in order to install the anchor blocks, which are shown on, if I scroll back, the anchor block is at the base of the tower, and the difficulty was because it was a very hilly type of outcrop. It was finding sufficient locations in which to position the anchor blocks. The number of anchor blocks was reduced from 12 to 11 because of the difficulty in finding suitable spots to locate them. Another important point was the installation of the platforms themselves. They had to be, the legs of the platforms were 2 meters in diameter, and a British company was commissioned, Fugo Secor, for arguably the most complex part of the operation, which was to drill the holes, the sockets, into which the legs of the platform would be dropped. And this proved to be a very challenging task, because the location for drilling was on the sloping rock that was covered with around about 10 meters of sand. So not only is there the challenge of drilling a vertical hole in a sloping rock, but also as that hole was being drilled, sand was pouring into the hole, clogging up the drill. Eventually a system was adopted whereby the sand was stabilized through the injection of a silica gel called water glass, which meant that the drilling could proceed efficiently without too much sand falling onto the drill. But this activity took a lot of time during the winter of 2012-13, while each of the sockets was drilled and each platform was positioned. This is one of the platforms being transported by barge. You can see it's got a pulling arm on the outboard side, which is to attach the Strand Jack cables. The weight of each platform was around about 1,000 tons. They were constructed on the eastern side of Italy at a yard called Rossetti, who are experts in constructing jackets for oil platforms. And this itself was the size of a medium-sized oil platform. And as I say, there were 6 of them. The next stage, once the platforms had been installed, was to prepare the wreck for accommodating what were known as the sponsons. These are buoyancy boxes. These were dropped onto the side of the wreck using a heavy lift vessel and welded onto purpose installed beams, which were reinforcing the side of the vessel. Because there was a need to fabricate these at very short notice, up to 5 of Italy's biggest shipyards were brought into play all operated by the shipbuilder Fincantieri. These were in Genoa, Ancona, Naples, Trieste, and Palermo. 30 sponsons were constructed in total, each weighing 600 to 800 tons. These are a sort of massive box, 10 meters by 10 meters by 30 meters high, reinforced in order to be able to take the forces for which are involved in the buoyancy and attachment. In addition to the sponsons on the side of the vessel, a purpose-built structure was created at the bow, which were known as the Blister Sponsons. These were to prevent additional deflection of the bow, and also they were used to attach the side sponsons in way of the bow. They were the blister tanks, as they were known, were constructed so as to perfectly match the shape of the bow of the wreck, and they had a weight of about 2,000 tons. They produced 6,000 tons buoyancy, and they were attached to the thruster tunnel of the vessel, the bow thrusters. This is an aerial drone shot of the wreck in about August 2013, and it's quite useful to see the different vessels that were mobilized in order to support the operation. At the top left, we have the ASV Pioneer, which was a work barge used to store and mix concrete grout, which was used to fill the space between the platforms and the shore in order to produce this stable platform onto which to rotate the wreck. Then to the right of that, we see the top of the towers, a barge here which was used for the micro piles for installing the towers, a couple of dive barges either side of the wreck. At any one time there was 3 dive teams operating on the wreck, each with a pair of divers, and there was a 24-hour rotation, which meant that we had up to 50 or 60 dive personnel on site at any one time. They were accommodated on board the ASV Pioneer and on board a heavy lift vessel called the Micopri 30, which had a 1,000-ton gantry crane on the stern. And you can see here that it's a transport barge is moored next to it. That was used for leaving things like the piles and other components before they were lifted onto the wreck. So it was an absolute hive of activity requiring very close coordination. All of these vessels are serviced on a daily basis by other vessels, barges coming from ports around Italy. This is the parbuckling sequence. It's a series of slides which show what the plan was to rotate the wreck. So we can see the port sponsons were welded to the side of the wreck. There were the Strand Jacks positioned on each of the four Strand Jacks on each sponson, for a total of around 40 Strand Jacks, or 36 actually, and a wire was connected to what was called the pull bar on the platform, and this was going to provide the rotational moment to bring the wreck over. The grout bags were positioned on the sloping part of the seabed and formed the bedding, let's say, onto which the rotation would occur. The plan was to pull the wreck upright. At this point, there was the maximum pulling force to be applied by the Strand Jacks. And at this point, the beauty of this system was that a very controlled rotation could be effected, because at a certain point, the buoyancy of the sponsons would take over. So effectively, from pulling the wreck over, we now had to very slowly lower it down onto the platforms by flooding the buoyancy boxes or sponsons on the port side of the wreck. And in this way, it was lowered onto a sandbox on top of the support platforms to give an even support along the length of the wreck. This series of slides basically shows the same thing in a 3D view, and we can see here the blister tank attached to the bow. These are the main series of vertical sponsons against which the Strand Jacks were attached, and yeah, the blister tanks had hooks for attachment of further buoyancy along the wreck. So the idea was to distribute the buoyancy evenly along the length of the wreck, so as not to sort of lift it from any particular point along its length, thereby inducing bending moments which could be dangerous and cause the wreck to crack. All of the sponsons on the opposite side, on the landward side, were going to be attached using these chains. So effectively, the chains had a dual purpose. One was to hold the wreck to the shore, and secondly, once the wreck had been parbuckled or turned, those chains would be disconnected from the shoreside towers, and those same chains would be used to connect sponsons on the opposite side of the wreck, on the side that had been resting against the seabed. So this is what the situation would be once the wreck had been rotated. During this time, so the preparations for rotation, there was a number of factors which meant that the target to refloat and get the wreck away by the summer of 2013 became unfeasible. Some of the reasons for this are listed here. There was a massive challenge for designing all the systems required, in particular the ballasting and compressed air network for the sponsons itself. The attachment systems of the sponsons, design of the Strand Jack arrangements, all took longer than expected. The mobilization of a drilling spread, finding the right contractor to do the drilling, the need for 6 platforms rather than 3, the installation of the anchor blocks, those are the base supports for the towers, for the holdback towers, required landscaping of the rocky underwater surface, which took much longer than expected. And the main cause of delay was these large diameter sockets, as I described. all of this just goes to show the types of challenges that are encountered on a wreck removal. It's totally unlike any other maritime or civil project, in that everything is done on the fly. The design, the mobilization, and the execution. There's no real lead time involved. So by December 2012, it was evident that the schedule would need to change. And at that point, it was decided that the refloating would not occur in the summer of 2013, at which point a decision had to be taken. Would it be better to parbuckle the wreck in 2013 and then leave it upright for the winter, or would it be better to leave it where it as is? So it had survived one winter, and the question was, well, if it survived one winter on its side, wouldn't it be better to leave it on its side, or should we press ahead and upright it and then hope that the wreck resting on the platforms remains intact and stable? A risk analysis was performed at this point to assist with the decision, and the conclusion was that it would be best to press ahead, parbuckle the wreck, secure it on the platforms, and then perform refloating during the summer months of the following year. Some of the input to this risk analysis was a prediction of the wave forces that could impact the hull during a particularly severe winter storm. In fact, we were quite lucky during the winter of 2013 that there was no really severe storms, but the wreck remained very, very stable on the platforms, which was a blessing, as it allowed the refloating operations to proceed without hindrance. So I'll now describe the process of uprighting the wreck. So taking a step back again, this is the position of the wreck, the commencement of the parbuckling operation. You can see in the foreground there's a command barge with the sensors and screens which were used to monitor the operation. And during this time, it was a sort of media sensation, with, again, the press descending on Giglio Island to see this sort of dramatic operation. When the wreck uprighting had to be delayed for a few hours while the chains were retensioned, there seemed to be sort of questions asked, but the process of removing wrecks does not sort of proceed on a minute-by-minute basis, so expectations had to be managed. One sort of amusing thing at this time is that the word parbuckle kind of entered the lingua franca, and including satirical articles about what parbuckling meant, and a website was set up to advise the public and interested people called the Parbuckling Project. And if you look up parbuckling, it will immediately alight on the Costa Concordia project. So this video shows the operation, which took place over a period of 18 hours. So it's a speeded up video, obviously. During this time, the Strand Jacks on top of the sponsons are being tensioned, and there is a critical moment, the questions were asked about whether or not the wreck would begin to rise. As you can see here, it did begin to rise. The tension that had to be applied by the Strand Jacks was within the design parameters, but a little bit on the high side. Around about 7,000 tons of combined force was required to bring it up. And at this point, there's a transition between pulling and resisting the overturning. And around about 3 or 4 a.m., the vessel very quickly rotated onto the platforms. So the cheering that you could hear, I think, was footage from the departure of the wreck from the island. This is a graph showing the process. What's important to note is that the circles denote the applied pulling force. The holdback force was very stable, so even although the wreck was being pulled, there wasn't a lot of resistance required at the base of the wreck. Obviously, the worry is, as you parbuckle, will you pull the wreck too far and actually pull it transversely across the platforms? This didn't occur. And as you can see, there was about 6,500 tons was the maximum combined pulling force required. Immediately following the parbuckling, surveys were carried out to assess the extent of damage of the wreck, the part that had been resting on the rocks. The damage was found to be quite limited to 2 particular areas. The accommodation itself, the superstructure, remained intact. And at this point, the preparations were made to begin attaching the sponsons on the starboard side, so the damaged side of the wreck. And this series of shots shows how it was done. The towers and holdbacks were removed. A number of sponsons were to be attached on the starboard side. Once all the sponsons had been attached, port and starboard, the sequence was to begin deballasting them, which would achieve 2 sets of 2 stages in the refloating process. And finally, the wreck would become fully buoyant and ready to be towed away from site. The starboard sponsons were very tricky to install because of the limited area between the wreck and the land, and in this case, another barge with a rotating crane had to be brought to site. This is a view of the sponsons arriving by barge, being lifted off, placed into the water, flooded, put alongside the wreck. Connecting the starboard sponsons couldn't be welded because at this point most of the wreck is underwater. They had to be connected to the chains, and a system of quick release and quick attachment shackles was designed to achieve that connection with minimal diver intervention. That's what we see here. On the left is a schematic of the attachment. On the right is a test that took place in a workshop to test its strength. So this is the wreck with the port and starboard sponsons now attached. You can see on top of the starboard sponsons, these strand jacks are used to pull the chains and tension those chains such that the sponsons remained attached to the starboard side. And this is a view once refloating had commenced. The refloating itself proceeded again in a very controlled manner, with the ground reaction reducing from 40,000 tons to nil, which meant effectively it was afloat. And the trim and heel of the wreck very controlled during the entire process, which lasted a period of about 1 week, while each of the sponsons was deballasted using compressed air to press out the floodwater. So they weren't pumped out. There was a use of compressed air. And again, the media descended for a third time on the island to watch this process. And again, it wasn't particularly dramatic, but it was spectacular. And here I've listed what we consider to be some of the technical innovations, like firsts in terms of a wreck removal for this project. There was the extensive use of strand jacks, over 100 strand jacks, which were used for all these different phases for holdback, parbuckling, and retaining of the sponsons. There was the ballast control system for the sponsons, so 30 different compartments that had to be individually deballasted, fully controlled. There had to be a redundancy system such that if there was a failure anywhere, there was a standby system to keep those sponsons empty. We discussed this water glass sodium silicate system to drill the holes for the platform legs. There was a need for grout cofferdams, which allowed drilling on the granite gradient. So once the hole had been commenced, an amount of grout was injected to stabilize the drill. Some other innovations, such as the use of a mining compound called green break to break some of the rocky pinnacles such that a flat surface could be achieved without using explosives, which would be very detrimental to the maritime life, such as dolphins. Sorry. The use of a DP2, that's a directionally positioned vessel to install the sponsons. So we've mobilized assets that have never been used before for salvage operations. And there was some engineering innovations to connect the strand jacks. There was during the time that the vessel was being parbuckled and refloated, there was a huge amount of preparation about where to take the wreck. Initially, the objective was to take it to a dedicated facility, perhaps in Turkey, or the challenge was that the wreck, even after it's been deballasted, would have a draft of 18 meters. And aside from dedicated offshore decommissioning facilities, some of which are in Norway, there's nowhere that is a dedicated recycling yard with such a depth to accommodate the vessel. One nascent plan was to transport the vessel on the world's largest heavy lift transport vessel called the Dockwise Vanguard at the time. It's now called the Boca Vanguard. And this would have been technically feasible, but it did present some additional risks in that if the semi-submersible barge, the Vanguard, couldn't meet the wreck, the refloated wreck, immediately due to schedule constraints, there might be a period of time where the wreck was afloat just waiting, and that wasn't acceptable. And during the refloating on the Dockwise Vanguard, all of the contents of the wreck would come pouring out and would need to be treated and captured, and that presented additional environmental risks. So we were quite lucky in that a facility was found in Genoa, and the plan was to bring the wreck alongside the breakwater next to the container berth, which is a deep water berth able to accommodate the 18 meters water depth, and a recycling facility was set up there to begin scrapping the wreck down deck by deck until it could be brought alongside the ship repair yard, which had obtained a license to conduct ship recycling work, and eventually the wreck hulk was brought into the dry dock in Genoa and scrapped down completely, a process that took almost 2 years to achieve, in taking account all of the sort of environmental sensitivities of taking apart a wreck in a highly populated area. Following that, the wreck site itself was subject to what we called site remediation. So every single component of subsea work was removed. The platforms were cut. The grout bags were removed, as we can see, using a purpose-built grab. And then a process basically of hoovering the seabed without removing the sand, but hoovering any sort of cement sediment and removing anything that had fallen out of the wreck was conducted. And it's in water depths of 30 meters plus. It required saturation divers who were operating from a diving bell for campaigns of up to a month to go down and manually, literally with their hands, pick things up off the seabed, place them in skips, which were lifted out. And then the marine biologists began a process of monitoring the damage and restoration of the seabed, which included the transplants of the native Posidonia seagrass, so that it would regrow in the area that had been shadowed by the wreck, really to bring this island back to a pristine condition. This shows a sort of plan view of the different areas that were subject to site remediation. And my sort of final concluding slide, sort of the, let's say, what went well. There was a very good coordination with the multiple authorities right from the outset, as it was very sensitive because of the search and rescue. The sort of the tragic human element to this had to be borne in mind. there was a sort of a huge political backlash within Italy itself, and sort of massive sensitivity around it. And so although there was a sort of a feeling that we should proceed as quickly as possible, everything had to be tempered to these sensitivities. In my view, the media exposure was way beyond what I could have ever imagined. And there was a need to constantly feed the media with reports on progress and manage their expectations, especially because of the challenges involved in wreck removal, the unpredictable nature of the schedule. The local population sort of suffered due to the impact on the tourist trade, and there was the need to sort of create as many opportunities to keep everyone on site, on board. So, for example, the fishing fleet was mobilized to work in an anti-pollution capacity. All of the personnel, there's 300 to 400 personnel from the salvors side, were accommodated almost exclusively on board the island, thereby keeping the hotels and restaurants busy. The environmental concerns were paramount. I mean, the whole idea of removing the wreck in one piece was to keep it as environmentally sort of friendly as possible. The challenges and any sort of setbacks had to be clearly communicated and explained. And there was a team, sort of sub-team involved solely on looking at optimizing the schedule and reducing the delays to the schedule. So, did we need a spare drill? Did we need spare platforms? One lost tool, one delay to a diver would cost sort of millions of dollars, could cost millions of dollars in terms of lost time. So getting everything as streamlined as possible was very, very important to us. The removal of large wrecks is a hugely expensive process because of the personnel involved, number of personnel, and the mobilization of marine assets is an expensive business. In this case, the cost of the removal was around about the $1 billion mark. But it was successful, and I think that was appreciated by all of the stakeholders involved in the project. That is the end of the presentation. So I'll hand back to Alistair. Thank you.
Unbelievable. Unbelievable. I think your margin for error on this whole project must have been minuscule. And the fact, as you say, that you were designing a lot of this work on the fly, not knowing it was going to work, is just incredible. The fact that you kept everything together, you kept the whole process together and structure, the fact that you kept the local and the community together as well, the fact you kept the media in check, that was probably one of the biggest achievements, I think, and that must have come under your role. I just think it's remarkable. I'm so grateful to hear that story. Thank you so much, Paris, to give your time, to give your expertise in describing a very complex project to, in this case, a number of laymen so very well and so very clearly. It's a memorable lecture. That's the best way to describe it. With that, may I just hand back for the minute, stay around, and if I can hand back to Jenny for a second.
Thank you. I just want to tell you that we're giving you a rest in August because we've heard so many people are away on holiday. So the next lecture will be the 12th of September at 6:30 on a Monday as usual. And it's going to be presented by John Horton. and the subject is Canadian naval art and war. So John is a famous artist, and we look forward to hearing from him on the 12th of September. Once again, you'll receive the information in due course, and hope you'll enjoy joining us again. I'm a layman, Paris, but I have found this absolutely fascinating. So I hope others have too. And as always, I make this plea for a donation, because we cannot survive without your support. We've got some really interesting educational projects on the cards. So if you can help us out, we'd be very pleased to have any donation, large or small. We're going to stay on for questions and wrap up. So Matt's going to let you in now while Alistair asks you a couple of questions, and then I will pick up on those that you've sent in.
Right, indeed. So there we go. Paris, you're across, which is great. Can you hear all right still?
Yes, yeah, thank you very much for
okay, that's fine.
the remarks. Yeah.
Those who are coming in will come in. It'll take a little while to come across for those who are coming in.
Mm-hmm.
We might give them a minute, Jenny, just so people are not losing the questions necessarily. You've got about 15 questions and comments,
All right.
so,
Okay.
which is good. Are people? Yes, we've got someone coming in. I'm not sure. Does everyone know exactly how this is done? How it comes across, Jenny?
Yes, you come in waves, and we can see you arriving. And when we've got a fair number, we'll pick up and start. So
good. Well, I hope people know that that's what's happening. There we are, a few coming in, which is good. Paris, on the personal front, how did you feel when the sponsors did their job and the ship was righted?
Was no doubt a relief, but we didn't see it as sometimes with wreck removal, you are it's sort of seat of your pants, and you've worked, perhaps there's a hurricane coming in, you've done all you can, and you've got a matter of 24 hours to refloat and take the thing away before the hurricane sweeps in this and then you really don't know, is it going to work or not, but you've got to take the chance. This was nothing like that. This was a fully engineered project, and as it progressed, as more money was spent, and as more commitments were made, and as it became clear that it wasn't just the stakeholders, the owners and the islanders of Giglio, but almost the entire sort of Italian establishment, political careers being made on the back of this. The stakes were so high that everything was basically double engineered to ensure that it worked. So personally, I didn't sort of feel at any point that oh, hang on, perhaps the worst that might happen would be a 24, 48 hour, week or two delay, but that could be managed.
Yeah, phenomenal. And you were backwards and forwards to the UK during this time, weren't you?
Yeah, I mean, normally the way we deal with wreck removal projects, we send one or two representatives. They stay on site for a few weeks or months. We like to have continuity, but in this case, it rapidly went from months to years, and my role became a sort of project manager rather than site representative, and we had a team of between 6 to 13 people just on the supervision side that I looked after. So I kind of went all over Italy, really, with meetings with authorities, owners, the planning designers, etc., and basically commuted from the UK.
Exactly. Have you? My last question is: have you had any wreck situations since that you've attended, which have been anywhere as near as complicated as this one?
No, not technically.
I gotta
But
say.
there's every wreck poses its own challenges, and usually it's the management of expectations. We've had things go very right and things go very wrong, where you might spend a year working towards something, and then suddenly the weather turns on you, and you go from, well, removal in one piece to, okay, we're picking up the bits now. And that's really that's the big gamble with wreck removal. If you go for removal as an intact, or in a few sections, chop it in 2-3 pieces and take them out. Yes, that's clean. Yes, it's quick, but you're exposing yourself to a big risk. And the sort of conservative option is, let's just sit there and slog it out, chop it up, and it might take years, but we can predict how long it's going to take, and it is going to work, but it might cause an awful lot of mess.
Sure. What is remarkable, hi Ted, gosh, from Australia, well done, good to see you. What is remarkable, Paris, is the fact that the question of pollution, of leakage from bunkers, was addressed straight away within 24 hours. And it seems there was no natural or environmental pollution that resulted. Is that correct?
Yeah, there was, initially there was some leakages from the wreck, because it had taken up an attitude of 60 degrees, so various oil can percolate out through air pipes, etc. So there was quite a lot of skimming and recovery in the first few days before the hot tapping took place. Then there was very limited pollution after that. There was 1 or 2 incidences where you're never going to get 100% of the oil out. There's always crevices and pockets, which even the most, when you hot tap 2 or 3 times on the same tank, there's always going to be some hydrocarbons left in. But really, with the amount of booming arrangements and anti-pollution vessels, there was zero impact on the environment, and that was monitored very closely, not only on a daily basis, but there was things like biomarkers, so various mollusks and crustaceans were used to detect if there was any pollutants coming from the wreck.
Fascinating. Look, we have a number of questions here. What I suggest, Jenny, perhaps, is can we just have a selection of questions, because I would love our good friends here who come back for the wash up afterwards, as we call it, to be able to talk and ask their own.
Absolutely. A question from Ned Larkin. If the wind had been blowing in the opposite direction, do you think there would have been another Titanic?
Yeah, I think this is my personal opinion. I mean, luckily it wasn't. There was an awful lot of luck involved. In hindsight, I think it could have been very disastrous. I mean, obviously the loss of 32 lives is a massive tragedy, but it could have been so much worse.
An anonymous attendee, was the water glass technique for the drilling a first, or had it been used before Concordia?
Not in a wreck removal context. I mean, we didn't invent the compound. I believe it was had been used in Holland, in some of their sort of coastal protection works. That was where the idea came from. But it took a lot of head scratching and sort of emergency meetings, and all sorts of ideas were put forward, because the days were slipping, days and weeks, and it was evolving into a slow crisis. If we couldn't put the platforms in, it just wasn't going to work. So,
Okay, from Vernon Stradling, the initial damage to the hull was on the port side, but the vessel ended up lying on its starboard side. Could you please explain how this occurred?
Yeah, So this was because of the cross flooding arrangements, so whereby the ballast tanks, some of the ballast tanks are interconnected port and starboard. So you, by breaching one side, actually it's designed to flood the opposite tank in order that you don't develop a very high list, which is important on a vessel such as a cruise vessel with quite relatively marginal stability, you know, compared to a tanker or bulk carrier. So effectively, it once it had spun round 180 degrees and the wind got it, perhaps it began contacting the ground, and it just had it had lost stability. It had a free surface with the engine room compartments which had flooded, and that's why it went over on the opposite side.
Okay, from Howard MW, were the portside sponsons ballasted before the parbuckling operation commenced, so that their gravity aided the turning moment, and did they have to be deballasted during the operation?
Yeah, that's a really good question. It was actually discussed during the engineering phase, but it was felt that we didn't want to impose any more weight on the wreck than was already there, because one of the concerns was collapse of the starboard bilge plating, effectively the fulcrum on which we were rotating the wreck. So although it might have saved, you know, as a discussion, well, okay, if we flood the sponsons, maybe we don't need the Strand Jacks, we don't need the pulling force. So it would have been cost and time saving, but it was determined that it would be better not to risk putting the additional load on that starboard side bilge plating.
Okay. From Ted Van Brunswick, prior to parbuckling, you mentioned the bilge protection. What was involved in that?
Yeah, that involved the installation of curved plates alongside the starboard bilge, which were used to guide and protect the wreck from the forces imposed by the chains, and also were used to sort of reinforce the bilge area during the rotation, so that it wouldn't collapse under the load of the ship on such a limited area.
Thank you. I'm going to run two questions together because they're quite similar. Were there changes to the design of cruise ships as a result of the Concordia wreck? And how safe would the speaker feel on one of these large cruise ships?
Right. In my capacity as naval architect, I ought to know the answer to that, even although it wasn't at all part of the project. There was a number of conferences held after this. I honestly don't know to what extent the damage stability requirements were altered. Certainly there was concern about flooding through fire doors, watertight doors in the engine room. So I think certain changes have been made to those arrangements. But on the whole, the stability is assessed in a probabilistic sense. So in in the past, a ship might be designed to survive any two compartments flooding. Now, a ship such as a cruise vessel is designed so that it can withstand. It's given a factor which is based on hundreds, if not thousands, of configurations of damage, and it has to survive them to an extent, and that sort of produces an index number, and the index number has got to be within a particular limit. It's very difficult to intuitively know which, if you flood a certain compartment, are you going to sink or not?
Yeah.
Immediately that they had 5 compartments flooded, they ought to have known straight away there was no hope.
Yeah.
But no, it's a good question. Apologies, I'm not able to give a concrete answer.
And what about going on a cruise ship yourself? I'm
Oh.
about to go on the Anthem of the Seas, which is very large. So I would like to know what your view is.
Yeah, no, I would have no hesitation at all. I'd certainly pay very close attention to the ship abandonment drill, and I'd definitely want to know my first and my second ways of exiting my cabin.
Yes.
I always do. But I think that's just sensible, but it certainly wouldn't stop me from going on one.
No,
Yeah,
good.
sure.
Well, thank you for that reassurance. There are more questions, but as Alistair says, we want to have a little chat. But I just want to say you've received a large number of thank yous for a very fine presentation. So thank you
Indeed.
very much.
Thank you again, Paris.
Back
So
to you, Alistair.
thank you so much, Jenny. Let's open it up, everyone. Can I welcome all our good international friends? Ted always said hi. A good question. Bruce over there, very good to see you indeed. Lovely to see you again. Holly, how lovely to see you.
It's so lovely to see you on my 68th birthday, July 11th, and I'm honored to be with all of you.
We're honored to have you, Holly. Thank you very much indeed.
Thank you,
Great.
Paris. Thank you for the presentation, and it's a miracle that there weren't more than 32 deaths and injuries on this ship.
I gotta say, it was one's heard stories or have suggested allegorical stories about what happened and how there was a degree of abandonment by the crew. I think that's actually been the subject of legal cases as well, but that's not for tonight. But the whole thing was just appalling and what happened in that short time. David, great to see you down in Cape. How are you? All right, Cape Town?
Yeah, fine. Hi, Alistair. Things are fine, and thank you so much for a very interesting talk. And it gave a good balance to what the way we viewed it, because it was all about Juan Salvador, Nick Sloan, who, according to the people in Cape Town, rescued the whole operation single-handed. And he found out. I heard 2 of his lectures, but Paris, you've given a much better balance to the whole operation, and thank you.
Very good indeed. Very
Thanks.
good. Who have we got down here? Oh, I got my brother down there, Andrew. Hi, Andrew. You won't be able to talk probably, but good to see you on. Who else do we have? Gosh, I don't know. But let me throw it open. I'll stop doing the talking. Anybody want to say anything at all?
Yeah, if I could.
Yeah, do.
Thank you, Paris. Fascinating lecture. I've always been curious about this type of thing, and I'm about to lose my battery, so I'm going to talk very quickly. $1 billion, nearly $1 billion, the final cost. I mean, what impact has that had on the maritime insurance globally, and if they made any changes to that?
Yeah, that's another very good question. I mean, it's there's different reinsurance layers that you go through. So the individual insurance company has quite a limited exposure, only a few percentage points before it goes to a pool reinsurance, and then it goes out to a special, like a catastrophe reinsurance policy that the entire the marine insurance industry has placed. So I mean, I'm not an insurance expert to tell you exactly how it's affected premiums, but what I do know is that it's very much viewed as a unique scenario, and although there has been some pressure to, you know, do another Costa Concordia when we get a major wreck. I think the Golden Ray in New Brunswick was possibly the second most expensive wreck removal operation. So there certainly it's had an impact on the cost of wreck removal. It's seen as one of the biggest exposures to marine liability insurers. But there hasn't been any fundamental change in the market arrangements as far as I can see.
Okay, thank you for that.
Great, good. Ted, how are things down in Sydney?
Well, it's wet weather as always. I said I probably should go back to the UK. It's much, from what I hear, it's much better up there. We just drew the short straw this year, so it's the 4th flooding event in Sydney, and I feel sorry for the people that were inundated all within 6 months, 4 times. So things are not looking that bright. But yeah, the ground is soggy. The golf course is out of action because the ducks are swimming across the greens. So we're just waiting for it all to dry out.
It's terrible, isn't it? It's been the wettest for a long time. And that's the real worry, isn't it? The ground's so soft, a bit of wind and the trees will go over.
Well, we've got a function coming up later this week, and we've invited Captain Skinner to go and talk to us. Chris Skinner, he's ex-Royal Australian Navy engineer and weapons engineer, and he's going to talk to us about the new nuclear submarines program that the government have decided on. I thought initially they might be opting for the Astute class British submarine, but it's at the moment we think it's going to be introduced into the American submarines. They may even buy one of the current ones off them until the new builds that we've ordered come in about 5 years' time. So, but in the meantime, it sounds like they're sending our officers over there for training.
Interesting indeed. It's a shame we lost it, but there it is. That's what the market is. Are they going to build some of those in Melbourne, or are they going to be built stateside, do you reckon?
At the moment, there's no talk about them being built there. They'll be serviced down in South Australia, but because they have a submarine, electric submarine base down there that they can do repairs on. The actual submarine bases themselves will be in Sydney and in Western Australia, in Perth.
All right.
So yeah, those are the two. They're both Garden Islands, by the way. I said Garden Island West and Garden Island East. But yeah, we'll see what happens in the long run.
Yeah, absolutely. Garden Island still as lively as ever would be. I mean, that sort of contract is going to keep it going forever, isn't it?
It is, yeah.
Yeah, which is great. I remember in Jaguar in 1971 coming alongside in Garden Island, HMS Jaguar. She was Cat class frigate, Lynx class frigate, ahead of the HMS Melbourne, the carrier in those days. And,
oh wow, that's a really nice, exciting story, because I still do cruises around the harbour on a charter boat, roughly about 80 people on board, up to 90 sometimes. Generally speaking, and it's to take people around to see all the historic sites. Like we recently had the 80th anniversary of the midget submarine attack on Sydney, so we had several days in a row where I took the boat out to go and show them all the installations, where the submarine net was and everything else. And then go back to what you were saying. When the shipbuilding was in ship repair during the war, we take them up there to Cockatoo Island to show them where the last of the Australian ships was built, and also all the other historic sites west of the Harbour Bridge. So yeah, quite interesting.
Exactly. Cockatoo is now. I mean, it's the atmosphere there is history, but there's nothing happening. It's just a big concrete slab now, isn't it?
No, Parks and Wildlife taken over, so they're conducting tours daily
Good.
And it's fully accessible by Sydney ferries that run up the river to Parramatta. So they
Oh, that's
all
good.
stop there.
Yeah.
You can go, come on, get on and get off the island as many times as you like. It's
Yeah.
quite easy, public transport on it, and you can see for yourself and go sightseeing. So the remaining docks that are there, they're being used as a marina, and the old ferries from Sydney are tied up there as well. So
Yeah, sure.
awaiting their future fate.
Yeah, the first fleeters. That's wonderful. Thanks, Ted. That's great to see you, and hi to Sandra as well.
Thank you.
That's great. Well, look, time is marching on. Poor old Paris is sat in his office in the city of London with a view that would be overlooking the River Thames. I'm not sure. Have you got a view there, Paris? You haven't, do you?
Yeah.
You have.
It's I don't know, for some reason the camera can't show it well.
Oh, there it is. Oh, that's not bad.
Nice, nice.
So we've just
Alistair, I have one question.
Beautiful.
Yeah. Is that you, Richard? Who was that asking?
Yeah, it was.
Yeah,
Alistair,
Richard. Hello.
Richard Rees. One
Hello.
question for Paris, and thank you for the view. Paris, it looks good. Very simple one. How do they get the chains under the vessel, under the bilge, to get your system in gear to start the pulling process to get it upright?
Yeah.
Without using duct.
Yeah, that's another exceptionally good question, and one that really preoccupied the team. In general, they were able to pull most. The wreck itself was supported on two sort of lines of rock with a gap in between. So
Lucky.
most of the chains could be pulled through by divers in this sort of valley underneath the midship section portion of the wreck. We considered there's a technique where you can use called directional drilling, which has been used in situations where you want to pull chains under a wreck that's perhaps lying on a muddy or silty or sandy seabed, but we didn't have to do it in this case. So in general, apart from a couple of chains where we had to do some sort of local removal with jackhammers to get them through past some rocks. In general, most of them were just passed in this through the valley, and that's why the holdback anchors, the towers, were all clustered together in a very short length compared to the length of the wreck.
And that pull closing in on those towers didn't induce additional strain on the hull coming into a point.
No. I mean the purpose of the holdbacks was only as a sort of safety measure, both during the possible rough weather and during the parbuckling.
Yeah.
So actually we were asked at the end, given this was months and many millions, did we really need the holdback? That was a question that came in the wash up. But again, it's easy to say with hindsight, but at the time it's very unpredictable to know what forces you're going to have.
Possibly. Well, it seemed like a great solution, and very different from the salvage that I was involved in, which was the Torrey Canyon.
Oh,
You
right.
may remember.
Heavens above.
Yeah.
And I spent a couple of days on board her before they trying to pump argon into her, it was a waste of time. It was all political. And if Andrew Morton, who was the RN salvage expert at Plymouth, had been allowed to do what he's supposed to do and take moorings down, put them alongside the wreck, pump the oil out into 2 RFAs, which we had in days, it would have been a much more simple operation, and certainly would have involved less mess.
Yeah.
And eventually she was,
Yeah.
And there's a little vignette to the bombing. The bombing was carried out by buccaneers from 809 Squadron in Blossy, and they were using delayed or retarded bombs, which they dropped very late. And quite a lot of these bombs did not fuse because the fuses didn't spin up enough time to make them live. So we've now got a few thousand pounders still rolling around 7 stones. More importantly, the Argentinians never learnt this. So in the Falklands War, most of their bombs initially were dropped safe until the BBC started talking about it.
A very great friend of mine was in the Plymouth in Carlos Water when they dropped these bombs at no height. And I think they took about, the old Plymouth took about 4 or 5 bombs, none of which went off. He said the place was like a Chinese laundry at the end of it. It was a mess. I think there were 4 sailors injured, and that was it. It was quite remarkable. It's interesting you say that, Richard, about fusing bombs as they spin.
Absolutely.
Thanks for your question. The Torrey Canyon, by the way, I think left that most awful heritage of damage to wildlife, didn't they? It went on for years afterwards.
Absolutely.
So sad. Look, I think probably time for that. It's time for Ted Van Bronson to go back to bed, I think. That time in the morning, and various places around the world. So I think it's a wrap. Again, Paris, I think we all join in saying thank you so much. And I hope you sleep very well after this one tonight. You've been working very hard on it.
Well, thanks for having me. It's great to have a really attentive audience, and yeah, the caliber of questions has been, I've given it half a dozen times, and there's been a demonstration of how attentive the audience have been. So thank you very much for that.
Our colleagues here are a very practiced audience. They're great. Every month on month, whatever the topic. Anyway, come back yourself, Paris. Good to see everybody. Good night. So don't come on in August.